Today I will show you a vehicle that began its journey as a strictly classified combat tank of the Soviet Union and which permanently changed global tank design. Friends, meet the legendary T-64, a vehicle that became a true revolution in military affairs. How did the designers manage to be the first in the world to introduce multi-layered composite armor and an automatic loading system on a mass-produced vehicle, forcing the North Atlantic Treaty Organization to urgently overhaul its tank programs? Why did the compact opposed piston engine, nicknamed the Suitcase by tankers, and the lightweight running gear become both the main advantage and the vulnerability of this tank? In this video, we will analyze in detail the history of the creation of this revolutionary machine. Be sure to watch the story to the very end. You will learn why this promising tank was ultimately phased out of production in 1987, due to what hidden defects the bottom of its hull cracked, and why the concept of the T-64 remains relevant even today. Let's begin. In Soviet tank building, it was customary to honor predecessors. Not to argue with them, not to break what works. Take something proven, improve it slightly, add engine power, increase armor, and there you go, a new tank. This is roughly how the T-44, T-54, and T-55 appeared. Reliable, mass-produced, predictable machines. Alexander Morozov did not accept this approach. This is important to understand right away because without it, the entire history of the T-64 loses its meaning. The tank was not just a new development, it was the designer's personal manifesto. Morozov did not want to make a better T-55. He wanted to close an entire era and open the next. His biography was fitting. He joined the design bureau in Kharkiv in the early 1930s as a very young specialist, at a time when the Soviet tank industry was being built virtually from scratch. He worked under the leadership of Mikhail Koshkin on the T-34. This is perhaps the only case in history where one can say about a tank, without any exaggeration, it changed the course of the largest armed conflict in human history. It did not just help, it did not just make a contribution, it changed it. When Koshkin passed away from an illness in 1940, contracted during a winter run of the vehicles to Moscow for a demonstration to Stalin, Morozov took over the bureau. After the end of World War II, it was his design bureau that developed the T-44, a tank that did not manage to take part in combat operations, but laid down the layout configuration that became the basis for the T-54 and T-55. More than 100,000 of these tanks were eventually produced worldwide. This figure is absolutely fantastic. No other tank has ever been produced in such numbers anywhere else. The T-54 and T-55 are still in service in some places, even though they are already over 70 years old. It would seem that with such a foundation, one could quietly continue to work in the same direction. But by the mid-1950s, Morozov came to a conclusion with which his colleagues at the time agreed reluctantly. The design layout had exhausted itself. Further improvement of the T-55 was a dead end. You could thicken the armor once more, install a larger gun, add horsepower to the engine, but at some point the machine would become too heavy, too large, and too expensive, and the combat capabilities would stop growing proportionally to the investment. A fundamentally different approach was needed. The problem Morozov faced looked at first glance like an ordinary engineering task. In reality, it was an almost philosophical contradiction that had haunted tank builders since the 1930s. Good protection requires thick armor. Thick armor means weight. Weight reduces mobility. And if you add engine power to compensate for the weight, the dimensions increase and the weight increases again. The circle closes. All designers in the world knew about this contradiction. They solved it in different ways. The Americans and British mostly sacrificed weight in favor of firepower, or vice versa. The Germans during World War II completely ignored the limits and created the Tigers and Panthers, magnificent machines, but so heavy that some of them simply sank when crossing rivers. Morozov decided not to choose what to sacrifice. He decided that the contradiction itself could be resolved, if solutions were applied that had never been used on production vehicles before. The new tank had to simultaneously protect the crew well, have powerful armament, and at the same time weigh no more than 35 tons. This technical specification was initially read in the military department with undisguised skepticism. Combining all this in one machine with such a weight limit? The designers in Nizhny Tagil, who were working on their own projects in parallel, openly doubted that this was even achievable. Morozov insisted on his way. He already had a reputation as a person who did not like the word impossible, although he understood well the difference between the impossible and the merely difficult. Even during the development of the T-54, he went beyond the agreed technical specifications regarding weight, and back then, this resulted in serious friction with the military customers. He remembered this experience well. That is why he was now ready to go to any design lengths just to keep the vehicle within the specified 35 tons. Work on the new tank began in the late 1950s. The Kharkiv Morozov Machine Building Design Bureau was at that time perhaps the strongest tank design bureau in the country, precisely because it was staffed by people who had gone through the development of the T-34, the evacuation of the plant during World War II, and the post-war recovery. This was a team with enormous practical experience, and at the same time, which is rare, a readiness to try fundamentally new approaches. The project received the working designation Object 432. In the Army, it would later be known as the T-64. What exactly Morozov and his team came up with will be discussed in the next section. But even now, it is worth pointing out the main thing. There was not a single component on this machine copied from its predecessors. The engine was new, the running gear was new, the armor was new, the autoloader was new. This was not an improved T-55. This was a different tank, a different philosophy, a different era. This is precisely why Western intelligence agencies, having received the first information about the new Soviet vehicle in the mid-1960s, sounded the alarm. And this is why the very revolutionary nature that made the T-64 outstanding eventually became the main reason for its difficult fate. In 1964, intelligence reports about a new Soviet tank began to appear in the headquarters of the North Atlantic Alliance. Initially, they were treated with caution. Intelligence often exaggerates. But the more details became known, the more serious the expressions became on the faces of the people reading these reports. The problem was not that the Soviet tank turned out to be slightly better than its Western counterparts. The problem was that it was designed fundamentally differently, and this differently shattered all existing calculations. Let's break it down in order. From the moment the first tanks appeared at the end of the First World War, armor worked on one principle. The thicker the steel plate, the harder it was to penetrate. The logic was simple, almost primal. If you want to protect the vehicle better, make the armor thicker. If you want thicker armor, accept that the tank will get heavier. This contradiction was one of the main ones in tank building for 40 years. The Germans during World War II relied on thickness and ended up with the 57-ton Tiger, a machine that got stuck on bridges and consumed resources in such quantities that there was not enough left for everything else. The Americans went a different way. They made the Sherman light and mass-produced, but paid for this with losses that the American tankers themselves described without sugarcoating. On the T-64, Morozov applied a completely different approach. The frontal part of the hull received multi-layered composite armor, 2 steel plates with a layer of fiberglass between them. The turret was cast with an aluminum filler. No monolithic steel, instead a layered pie of different materials. Why? Because in the 1960s, tanks faced 2 fundamentally different enemies, and monolithic steel could not cope equally well with both. The first was the armor-piercing, fin-stabilized, discarding sabot round. In essence, this is a tungsten or steel rod accelerated by a gun to a huge speed. It does not explode. It simply flies and penetrates armor with raw kinetic force, much like a drill, only in 1,000th of a second. For such a projectile, the main thing is to maintain stability in flight and upon entering the armor. When it encounters heterogeneous layers of different density and elasticity along its path, it begins to veer to the side. The tip of the core loses its direction, the projectile stops working like a drill, and begins to work like a broken needle. The penetration capability drops sharply. The second enemy was the high-explosive anti-tank chemical energy warhead. This is an anti-tank grenade or rocket in which a cleverly designed explosive charge, when detonated, forms a thin, high-speed jet of superplastic metal. The temperature is thousands of degrees, the pressure is colossal. This jet literally burns through steel, like a red-hot needle through butter. Monolithic armor is practically helpless against it, no matter how thick it is. But heterogeneous materials disrupt it. The jet disperses, loses coherence, and its energy is deflected to the sides. Morozov's composite armor worked against both types of ammunition simultaneously, and at the same time, it weighed significantly less than a monolithic steel plate of equivalent protection. In the West, the idea of spaced armor, that is, armor with air gaps between the layers, had been discussed for a long time, but it was Soviet designers who managed to be the first to implement a composite, multi-layered structure on a production tank. The British Chobham armor, which later became the standard for the Abrams, Leopard II, and Challenger, appeared later, and was developed with a direct eye on what had been learned about the T-64. In any tank of that time, the crew consisted of 4 people. The commander monitored the situation and assigned tasks. The gunner operated the weapon and aimed. The driver mechanic drove the vehicle. And the loader, the person whose duty it was to grab a shell weighing from 7 to 20 kilograms, ram it into the breech of the gun, and follow it with a separate propellant charge. Over and over again, under fire, in a hot turret, in clouds of powder smoke. The work was physically hard, but most importantly, it required space. The loader had to fit in the turret, be able to move normally, and reach the ammunition storage. It was because of the loader that the turrets of Soviet and Western tanks were so large. A large turret is a large target. A large target means more chances of being hit. The automatic loader on the T-64 removed the loader from the crew entirely. The carousel-type mechanism was located in the lower part of the turret. The projectile and the propellant charge were stored in it separately. At the gunner's command, the mechanism itself selected the required type of ammunition, fed it to the breech, and rammed it into the gun, all of this in a few seconds. The French AMX-13 light tank in the early 1950s also had an automatic loader, but it had a fundamental limitation. The mechanism could only load the gun at a certain elevation angle. That is, the gunner had to temporarily take the gun off target, reload, and look for the target again. In a real clash, these are lost seconds, and seconds in a tank engagement matter. The Soviet autoloader loaded the gun right in the process of aiming. While the gunner kept the sight on the target, the mechanism was already ramming the next round. The result? The rate of fire increased from 2 rounds per minute, which is what a good loader could provide in manual mode, to 10 rounds per minute with the autoloader. This is not an improvement of a few percent. This is a 5-fold increase. In addition to the rate of fire, reducing the crew from 4 to 3 people made it possible to shrink the turret. A smaller turret meant less weight, which allowed for thicker armor without increasing the overall mass. All of this led to one thing. For the same 35 tons, Morozov obtained a significantly more protected and combat-capable vehicle than his competitors. The first production T-64s carried a 115mm D-68 smoothbore gun. In itself, it was a serious weapon. Smoothbore guns, without rifling on the inner surface of the barrel, accelerate projectiles to higher muzzle velocities than rifled ones. Less friction, fewer energy losses. For subcaliber ammunition, this is critically important. But the real step forward was the T-64A modification with the new 125mm D81T smoothbore gun. At the time of its adoption into service, it was the largest caliber tank gun in the world. No one else had anything like it. A 10mm difference in caliber, from 115 to 125, sounds modest at first glance. But in ballistics, these are completely different figures. The volume of the projectile and the propellant charge grows not linearly, but proportionally to the square of the radius. In other words, a 125mm projectile of the same length has a significantly larger volume and mass than a 115mm one, and carries proportionally more energy. What did this give in practice? First of all, a subcaliber projectile with higher kinetic energy, capable of penetrating armor that the 115mm gun could no longer breach. But more importantly, the 125mm caliber allowed for the use of full-fledged, high-power, high-explosive fragmentation shells. The tank stopped being a highly specialized armored vehicle destroyer and became a universal combat vehicle. This gun eventually became the standard of Soviet tank building for the next half-century. It is installed on the T-72, T-80, and T-90. With modifications, it is used on the Russian T-14 Armata. The D-81T outlived the tank for which it was created and continues to serve to this day. When the intelligence picture on the T-64 became sufficiently complete, concrete work began in the headquarters of the North Atlantic Alliance. No discussions, no committees, actual work. Because it became clear, Existing Western tanks could not fight this vehicle on equal terms. In the United States of America, work on the XM-1 project, the future Abrams, was significantly accelerated. The previous XM-803 project was closed as not promising enough. The Americans, together with West Germany, were also developing a unified main combat tank, the MBT-70, main battle tank of the 70s. The project eventually reached a dead end. The Allies could not agree on the requirements. The program was closed in 1971, having spent huge amounts of money without producing a single production vehicle. In Great Britain, work was underway on the MBT-80 project, a new main battle tank that eventually transformed into the Challenger 1. In West Germany, work continued on the Leopard 2. All of these programs differed in terms of deadlines, approaches, and results. But they have one common feature. They all started or were sharply accelerated after Western military officials realized what exactly was being done in Kharkiv. The T-64, a tank that did not participate in a single major armed clash with Western armies, nevertheless reshaped all Western tank building for the next 20 years. This is perhaps the best way to assess how serious this machine was. However, behind all this brilliance, there was another story, a much less celebratory one. More about it in the next section. There is a pattern in the history of technology. The more revolutionary a machine is on paper, the harder it falls when encountering reality. The first generations of steam locomotives exploded. The first airplanes fell apart in the air. The first cars stalled every few kilometers. This did not mean the idea was bad. It meant that between the idea and a reliably working production product lay a chasm that could not be leaped over. It could only be crossed slowly. With the T-64, this story repeated itself, but under particularly awkward circumstances. The tank was put into mass production in 1963. The plant in Kharkiv began producing the vehicles. But there was a catch. Up until the end of 1966, the tank was never able to pass full-scale trials. 3+ years of mass production, and the vehicle was still officially listed as experimental. All documentation went with the letter O, meaning experimental prototype of the chief designer. This was an industrial euphemism meaning roughly the following. The factory makes tanks, the army receives them, but no one is ready to officially say they are ready for real service. Only at the very end of December 1966 was the T-64 finally adopted into service. But even after this, fine-tuning continued for several years. Why did it turn out this way? For very specific reasons, and they are worth breaking down one by one. The main problem was the engine. Not the most noticeable component from the outside, but it was what determined whether the tank would run or not. Morozov put a fundamentally new engine on the T-64, a 2-stroke diesel with an opposed cylinder layout designated 5TD, and in its supercharged version, 5TDF. The opposed layout meant that the cylinders were located not vertically, as in a conventional engine, but horizontally, in pairs, facing each other. The design turned out to be very flat, so flat that the tankers nicknamed the engine the Suitcase, and this nickname conveys the essence more accurately than any technical description. The supercharged 5TDF version developed 700 horsepower. At the same time, it was significantly more compact than the traditional V55V engine used on the T-62, which, despite its larger dimensions, produced only 580 horsepower. Thanks to the Suitcase, the engine transmission compartment was reduced so much that the T-64 turned out to be 20 centimeters lower in hull height than the T-62, and yet its ground clearance was 4.5 centimeters larger. This really looked like an engineering miracle. Except that this miracle engine worked unreliably, completely. In summer it overheated. In winter it refused to start. It was so demanding of the quality of oil and fuel that any deviation from the standard threatened a breakdown. The cooling system had a feature that one might want to call a design feature, but to be honest, it was a trap. If the antifreeze leaked and the mechanic added ordinary water to the system, the cooling jacket channels instantly became covered with scale and the engine seized. Not after some time, immediately. The official instructions for the tank contained a recommendation that was in itself an admission of the problem. Assign only highly qualified driver mechanics with extensive practical experience to the T-64. But even this helped little. Experienced tankers who had worked for years with the V2 engine and its successors found themselves in front of completely unfamiliar technology. All accumulated experience did not work. They had to learn anew, from scratch. This created a vicious circle. Complicated maintenance meant fewer people managed it correctly. Fewer people managing it meant the machine broke down more often. The machine breaking down more often meant the commanders did not like it. The commanders not liking it meant it received neither a good reputation nor sufficient funding for refinement. The engine was not the only source of trouble. The running gear also brought surprises. Morozov used 6 small road wheels on each side of the T-64, compared to 5 large wheels on the T-62. The wheels were made of aluminum alloy and equipped with internal shock absorption. The first 2 and the last wheels on each side received additional hydraulic shock absorbers. On top, support rollers were added on each side, similar to those on heavy tanks of the World War II era, like the Kliment Voroshilov and Iosif Stalin. In terms of smoothness of ride, the T-64 surpassed its predecessors noticeably. This was visible both during testing and in real operation. But during intensive use, on long marches and at high speeds over rough terrain, the small road wheels could not cope with the impact loads. Shock absorbers failed en masse, not isolated failures, but systemic ones, on many vehicles at the same time. This was a design defect, not accidental malfunctions. A separate story was the torsion bars, elastic suspension elements working in twist. Morozov used short coaxial torsion bars made of a special high-plasticity alloy. The engineering solution was elegant, but the torsion bars were attached at their ends in the middle of the hull bottom, and the bottom was relatively thin in this very place. Again, a consequence of the struggle for every kilogram. Under repeated cyclic loads, fatigue accumulated in the metal, and at some point, the bottom cracked. There were cases when the attachment point of the torsion bar was ripped out entirely. If this happened in the rear part, the fragments damaged the assemblies in the engine transmission compartment. That is, one breakdown dragged another after it. There was another problem that was spoken of most quietly, because it concerned not reliability, but the concept. The desire to fit into 35 tons at all costs led to an extremely tight layout. The 3 crew members found themselves literally surrounded by ammunition and fuel tanks. This was fully justified in a head-on clash, where the enemy attacks from the front, where the armor is thickest. But when hit in the side or rear, directions where the armor is significantly weaker, the probability of fire and ammunition detonation was high. This was not an accidental flaw. It was a conscious design decision dictated by the weight limit. Morozov understood perfectly well what he was doing, but in his opinion, there was no choice. Either a tight layout at 35 tons, or a safer one, but then it would be 40 tons and a completely different machine. Let us recall, it was exceeding the weight limit during the development of the T-54 that became the source of serious friction with the military department. Morozov learned this lesson well, and on the T-64, he held on to 35 tons with his teeth. The sum of all these problems led to a decision that speaks for itself. The T-64 began to be deployed only in units located in the immediate vicinity of 2 points: the manufacturing plant in Kharkiv and the repair plant in Lviv. In other words, the vehicle was tied to specific geographic locations, because without qualified maintenance and rapid repair, it was unreliable. This was in itself a sentence for equipment that was intended to become the basis of mobile armored formations capable of operating at great distances from supply bases. Nevertheless, the work on refinement did not stop. The Kharkiv Design Bureau methodically eliminated problem after problem. By the mid-1970s, the reliability of the machine reached an acceptable level. But during this time, something changed. In Nizhny Tagil, they made their own tank, and this tank turned out to be a completely different answer to the same question. There is a moment in the life of almost any complex technical system when the initial chaos of development ends and the machine finally becomes what it was meant to be from the very beginning. For the T-64, this moment was the appearance of the T-64A modification. But before talking about what changed, it is worth saying honestly how much time was required for this. The basic T-64 was adopted into service at the end of 1966. The T-64A began to enter units in 1969. 3 years of modifications, changes, and corrections, and the result was a machine that was no longer embarrassing to put on the front line. The main innovation of the T-64A was the replacement of the gun. The basic 115mm smoothbore D68 gun gave way to the 125mm Smoothbore D81T gun. At the time the T-64A was adopted, it was the largest caliber tank gun in the world. No production tank in any country carried anything like it then. The autoloader was completely redesigned for the new, larger ammunition. The principle remained the same: a carousel mechanism in the lower part of the turret, separate storage of the projectile and propellant charge, and automatic feeding. But the design was brought to fruition. Some of the reliability problems that plagued the basic version were eliminated. The T-64A received a two-plane gun stabilizer. This is a device that keeps the barrel pointed in the chosen direction, regardless of how the tank hull moves and sways. The vehicle drives over rough terrain, the hull tilts and bounces on bumps, but the barrel remains directed where the gunner aimed it. This is called firing on the move, and it is the stabilizer that makes it possible. A stereoscopic rangefinder sight was added. What was its purpose? Accurate hitting of a target from the first shot requires knowing the distance to it. An experienced gunner could estimate the distance by eye, but this was always an estimate with a margin of error. The stereoscopic rangefinder worked on the principle of human binocular vision. Two separate optical channels captured parallax, a slight angular displacement of the target image, and calculated the distance from it. Accuracy was significantly higher than with visual estimation. A night vision device allowed the crew to work in the dark. Before this, tanks were practically blind at night. They either stood still or moved with headlights on, revealing themselves for kilometers. On the T-64A, the anti-aircraft 12.7mm machine gun became remote-controlled for the first time in Soviet tank building. The commander could aim it and fire at low-flying targets without leaving the turret, using a special sight. It sounds like an obvious solution, but it was never fully implemented on either the T-72 or the T-80. On those vehicles, the commander was still forced to lean out of the hatch to operate the anti-aircraft machine gun. The T-64A was ahead of its contemporaries in this respect, both domestic and foreign. By the early 1970s, the T-64A took the place for which the entire project was originally intended. It was used to equip Guards formations, elite units of the Soviet Army. And most telling, it was the T-64A that became the main tank of the group of Soviet forces in Germany. The group of Soviet forces in Germany was the largest permanent deployment of Soviet forces outside the USSR. Dozens of divisions, thousands of units of equipment, located on the territory of the German Democratic Republic, that is, in the immediate vicinity of the border with West Germany and the troops of the North Atlantic Alliance. It was here that the best of what Soviet armor technology had was concentrated. The fact that the T-64A ended up here speaks louder than any official evaluations. The T-72 went to second-line units and the Allied armies of the Warsaw Pact organization. This division was fundamental and unspoken, the best to the front line, the simpler to everyone else. The T-64A was an outstanding machine. In terms of the combination of characteristics, firepower, protection, mobility, it had no equal among production tanks in the world at the turn of the 1970s. But it still had one fundamental limitation that no modernization could completely eliminate. It could only be produced in Kharkiv, one plant for the entire Soviet Union. Production capacity was limited, maintenance was demanding, crews required high qualifications. Spare parts for the 5 TDF engine were specific and not used anywhere else. And while Kharkiv was making the T-64A, in Nizhny Tagil they were making something else, less sophisticated, less technologically complex, but in significantly larger quantities and without being tied to one specific plant. What came of this is in the next section. In the Soviet tank industry, there was an unspoken rivalry that was not written about in open sources, but which everyone understood perfectly. On one side was Kharkiv, Morozov's design bureau, a tradition of technological boldness and engineering sophistication. On the other was Nizhny Tagil, Uralvagonzavod, a tradition of mass production and practical reliability. These were not just two competing enterprises, these were two different philosophies of what a tank should be. And at the end of the 1960s, Nizhny Tagil gave its answer. The history of the T-72 does not begin from scratch. The chief designer of Uralvagonzavod, Leonid Kartsev, received a task in the early 1960s to create a simplified version of the T-64, suitable for mass production on a broad industrial base. Not to replace the Kharkiv machine, but to simplify it enough to produce it not at one plant, but at several. Karousel took on the task and gradually came to the conclusion that simplifying the T-64 to the required level while maintaining its combat capabilities was practically impossible. Too many things were interconnected there. Remove one revolutionary assembly and the whole concept collapses. Leave it, and you get the same problems with production and maintenance. Then the Nizhny Tagil designers went another way. They stopped thinking about simplifying the T-64 and began thinking about creating a fundamentally different machine, with the same combat missions, but with a different engineering philosophy. In 1973, the tank with the index T-72 was adopted into service, and it was immediately discovered that this was not a simplified T-64. This was a completely independent concept. In terms of armament, the T-72 and T-64A were identical. The same 125mm D81T smoothbore gun, the same Carousel-type autoloader principle, the same ammunition. But the similarity ended there. The engine on the T-72 was the V46, a diesel engine with a capacity of about 780 horsepower. Compared to the Suitcase 5 TDF, it was significantly larger. It occupied more space in the engine transmission compartment, which meant the hull of the T-72 was higher than that of the T-64. This was a step backward in layout, but the V46 had one quality that outweighed all these shortcomings. It was understandable. Its design traced back to the legendary V2 engine, the very one that was installed on the T-34 during World War II. Every Soviet tank mechanic, every repairman in any part of the country knew this design. They knew how to maintain it. They knew how to fix it in field conditions with a minimal set of tools. The same could not be said about the 5 TDF. The running gear of the T-72 was also designed differently. 6 large road wheels per side, compared to 6 small ones on the T-64. A simple torsion bar suspension without any sophisticated coaxial structures made of special alloys. Less elegant? Yes. More bulky? Also yes. But this running gear had one fundamental advantage that was fully revealed only later: a huge margin of safety. When, in the course of subsequent modernizations, the T-72 began to get heavier, first to 44 tons, then to 46, in some versions almost to 47, the running gear withstood this weight growth practically without design changes. The T-64 running gear did not have such a margin. The T-64 could only be produced at the Kharkiv Nizhny factory, one enterprise, one production site, one point on which everything depended. The T-72 could be produced at Uralvagonzavod in Nizhny Tagil, at the Chelyabinsk tractor plant, and at the plant in Omsk. If necessary, production could be deployed at other enterprises that had suitable machine tool facilities. In Soviet military planning, there was a concept of a mobilization tank, a machine that, in case of need, industry could produce in the maximum possible quantities, using all available capacities. The T-72 fit this definition perfectly. The T-64 did not. By 1987, when production of the T-64 was finally stopped, about 13,000 units of all modifications had been produced. But the T-72 by the same time had crossed the 30,000 mark, and it continued to be produced. In Russia, it was produced until 2005. Licensed production took place in Poland, Czechoslovakia, Yugoslavia, India, and Iran. The total world production of all versions of the T-72, taking into account licensed copies, is close to 40,000. The T-64 was never exported anywhere. Everything that was produced remained in the Soviet Union. Was the T-72 better than the T-64? No. In terms of combat characteristics, firepower, protection, accuracy of fire, the T-64A and T-64B were at least not inferior to the corresponding versions of the T-72, and in a number of parameters they surpassed them. A remote-controlled anti-aircraft machine gun, which was not on any T-72. A lower silhouette, higher power-to-weight ratio with lower weight. The T-72 was not better, it was different. It solved another problem: to be not the most perfect, but the most accessible. To be produced anywhere, maintained by anyone, and to work in any climatic conditions without special preparation of the crew. In this sense, the T-72 did not win a technical competition, it won a production and logistical competition. And it is this competition, as history shows, that is more important in the long run. Morozov understood this, but he could no longer change anything. There is a bitter irony in the fact that the most advanced version of the T-64 appeared precisely when the fate of the machine was actually already decided. The T-64B was adopted into service in 1976, the very year when the T-80 began to enter service. Kharkiv presented its best tank at the exact moment when Leningrad was already preparing to take its place. But this does not detract from what the T-64B was. In terms of the combination of characteristics at the time of its adoption into service, it had no analogs anywhere in the world. The main innovation of the T-64B was the Kobra guided missile system, official designation 9K112. The idea sounds strange at first glance, launching anti-tank missiles through the barrel of a tank gun. The 9M112 missile looks like a large artillery shell and is stored in the same carousel of the autoloader as conventional ammunition. The crew does not do anything special to use it, they simply select the required type of ammunition. The autoloader feeds the missile to the breech just as it feeds a conventional shell. After firing, the missile exits the barrel, turns on its engine, and is guided along a laser beam. The gunner keeps the reticle on the target, the laser continuously illuminates the target, and the missile flies to the intersection of the beam with the target. The destruction range was up to 4 kilometers. This was a fundamentally important figure. Standard armor-piercing subcaliber shells of that time were effective at distances of up to 2 to 2.5 kilometers. At long distances, the shell lost speed and accuracy. The Kobra missile worked where the shell could no longer cope. The ability to shoot conventional shells at the same time did not disappear. The crew could switch from missile to shell and back at any time. The tank received a ballistic computer. To understand what this changed, you need to understand how the gunner worked without it. Hitting a target from a tank gun is a much more difficult task than it seems. The projectile deflects downwards under the action of gravity. The wind drifts it to the side. If the tank is moving, you need to lead the target. If the target is moving, even more so. Air temperature affects atmospheric density. Barrel wear changes the initial velocity of the projectile. The ballistic computer removed the human factor from this equation. Sensors automatically measured wind speed, roll angle, air temperature, and the speed of the tank's own movement. The rangefinder determined the exact distance to the target. The computer instantly recalculated all parameters and automatically made corrections to the sight. The gunner only had to aim the reticle at the target and press the button. Everything else was done by the computer. In the mid-1980s, the T-64B received the Contact Explosive Reactive Armor Complex. The complex consists of small rectangular modules, inside each of which is a plate of explosive between 2 steel sheets. When hit by a shape-charged projectile, it detonates on the contact module. The explosion of the module creates a counterflow of metal and explosive gases, which destroys the shape-charged jet before it reaches the main armor. Against shape-charge ammunition, which in the 1980s formed the basis of infantry anti-tank weapons, Contact gave a multiple increase in protection. The T-64B tank with the full set of Contact in the early 1980s was one of the most protected production tanks in the world. And here's the main paradox of the entire history of the T-64B. The machine was classified, deeply and consistently. It was not shown to allies in the Warsaw Pact organization. It was not sold for export. It was practically not mentioned in open Soviet sources. The T-72, meanwhile, participated in real clashes. In 1973, in the Middle East as part of Syrian and Egyptian forces. In the 1980s, in the Iran-Iraq conflict. Wherever it appeared, it was studied, analyzed, and conclusions were drawn. It was known. The T-64B remained in the shadows. When the T-80 appeared in 1976, talks about the fate of the T-64 became increasingly definite. Not urgent, for another 11 years, the machine continued to be produced and improved. But the direction was set. In 1976, a tank entered service with the Soviet Army that was unlike anything the Army had seen before. Not in terms of appearance. From the outside, the T-80 resembled the T-64, with which it had an obvious design relationship. It was unlike it in terms of what was happening inside, in the engine transmission compartment. There was a gas turbine power plant, not a diesel one. Gas turbine engines had already been working successfully in aviation for a long time. Jet aircraft had been flying on them since the late 1940s. The principle is simple. Air is compressed by a compressor, mixed with fuel, burned, and the flow of hot gases spins the turbine, which delivers power to the shaft. In the Soviet Union, work on a gas turbine tank was carried out by the Leningrad Kirov plant, the very enterprise that produced heavy Kliment-Voroshilov tanks during World War II. After the end of hostilities, the plant took up a fundamentally new direction, and by the mid-1970s, it brought the gas turbine power plant to a state suitable for mass production. The engine received the designation GTD-1000T, a gas turbine engine with a capacity of 1,000 horsepower. This was an outstanding figure at the time. The 5 TDF on the T-64 developed 700 horsepower, and the V-46 on the T-72 developed about 780. The Leningrad engine exceeded them in power by a third or more. The T-80, with a combat mass of about 42 tons, had a power-to-weight ratio of about 24 horsepower per ton. This was an exceptional indicator for a production tank. The T-64A, with a lower mass, had about 18 horsepower per ton, and the T-72 had about 19. The T-80 accelerated faster, significantly faster. On rough terrain, where it is constantly required to accelerate, overcome obstacles, or sharply change direction, this advantage manifested itself fully. A separate advantage was the cold start. Diesel engines start with difficulty in severe frost. The 5 TDF on the T-64 was particularly temperamental in this regard. The GTD-1000T gas turbine started at -40 degrees as easily as at +20. In terms of armament, the T-80 completely repeated the T-64B. The same 125mm D-81T smoothbore gun, the same Carousel autoloader, the same capability to launch guided missiles through the barrel, the same fire control system with a ballistic computer. The T-80 also received contact reactive armor, in roughly the same time frame as the T-64B. The fuel consumption of the gas turbine was indeed high. On the highway, the T-80 consumed about 450 liters of fuel per 100 kilometers. This is almost twice as much as the diesel T-72. The range was about 335 kilometers against 460 to 500 for the T-72. The turbine required high-quality maintenance of air filters. In dusty conditions, steppes, deserts, dirt roads in dry weather, abrasive wear of the compressor blades was noticeable. The cost of production and maintenance was higher than that of the T-72. For the T-64, the appearance of the T-80 meant one thing: its place on the front line was taken. As long as the T-80 did not exist, the T-64 was the only tank the Army considered good enough for first-line guards units. After the appearance of the T-80, the situation changed. The tip of the spear was the T-80. The mass base was the T-72. The T-64 did not fit in either place. The decision matured over several years. It was officially made in 1987. Production of the T-64 was stopped. The last machines left the assembly line of the Kharkiv plant quietly, without any official ceremonies. Just at some point, the conveyor stopped, and that was it. Morozov had already passed away 8 years before. He did not see this finale. Perhaps it was for the best. When production of the T-64 was stopped in 1987, there were neither loud discussions nor public explanations in Soviet military circles. The decision was made, formalized, and executed. That was it. But the question remained: why was a vehicle that surpassed most of its contemporaries in combat characteristics produced less, exported less, and removed from production earlier than the significantly simpler T-72? An honest answer does not fit into one reason. When an engineer takes on a fundamentally new solution, he has two paths. The first is to test this solution on something less critical, accumulate experience, identify problems in controlled conditions, and only then transfer it to a production machine. The second is to implement it immediately, counting on the fact that the problems will be identified and eliminated in the process of operation. Morozov chose the second path, and on all key assemblies simultaneously. A new engine that had never been used anywhere before. A new running gear with unusual road wheels and torsion bars. A new armor layout that had no precedent. A new autoloader. A reduced crew. Each of these solutions individually required years of refinement. When they were assembled in one machine, the problems began to accumulate and interact. The T-72 in this respect was designed fundamentally differently. The new features there were the armament, the gun, and the autoloader. Everything else dated back to proven solutions with a long history. This meant that the problems, if they arose, were local and predictable, not systemic. The desire to fit into 35 tons at all costs led to an extremely tight layout. There was not a single extra centimeter, not a single extra kilogram in the machine. Excellent specific characteristics, but no reserve for growth. Any production tank in the process of operation and modernization gets heavier. Over 20 years of service, a machine that started life at 36 tons can easily gain 43 to 45 tons. The running gear of the T-64 could not withstand this. The running gear of the T-72, on the contrary, without any fundamental changes, withstood a weight growth from 41 tons to almost 47 tons in the heaviest modifications. The T-64 could only be produced at the Kharkiv Nizhny factory. The 5 TDF engine required specialized production equipment that was not available anywhere else. The T-72 could be produced at several factories simultaneously. In Soviet military planning, this was of fundamental importance. The 5 TDF engine, for all its temperamental nature, had an indisputable advantage. With very small dimensions, it gave 700 horsepower. As long as the V2 and its successors produced no more than 580 to 600 horsepower, this advantage was real. But in 1973, the V46 engine with a capacity of about 780 horsepower was put on the T-72. The gap between the machines in terms of power-to-weight ratio became minimal. The main trump card of the 5 TDF stopped being a decisive argument, and all its downsides remained. Until 1976, the T-64 had a clear place in the hierarchy, the best Soviet tank. After 1976, this stopped being true. The T-80 surpassed the T-64 in dynamics, was produced independently of Kharkiv, and carried the same armament. When the best guards units began to switch to the T-80, the T-64 found itself without its main role. The T-72 participated in real clashes. It was studied, dismantled, and analyzed. A real reputation grew around it, not perfect, but real. The T-64 did not participate in real clashes until the collapse of the Soviet Union. The commanders who had to rely on it had neither real experience working with it, nor the confidence that comes only through practice. The T-64 was not a bad tank. It did not coincide with reality, with the army that operated it, with the industrial system that produced it, and with the scalability requirements that Soviet military doctrine imposed on equipment. An excellent tank for ideal conditions, an insufficiently flexible system for real conditions. It was this contradiction that 1987 resolved. When production of the T-64 was stopped in 1987, it seemed that the story was over. But equipment with a good design foundation rarely dies completely. It goes into the shadows and returns. With the T-64, this is exactly what happened. In 1991, the Soviet Union ceased to exist. The Kharkiv Nizhny factory, now located on the territory of an independent state, inherited a unique position. It was the only enterprise in the world that knew how to produce and maintain the T-64. The entire design bureau, all technological documentation, and all personnel, all of this remained in one place. A large portion of the tanks themselves was also concentrated on the territory of the same state. When the army divided along new borders, thousands of T-64s of all modifications found themselves at the disposal of a state that had previously had no independent tank building industry. Now it did, and it had to be decided what to do with them. In 1999, the first serious post-Soviet modernization appeared. The tank received the designation T-64BM, Bulat. First of all, protection. The Bulat received the new Nozh reactive armor complex, developed by the Kharkiv Design Bureau. In terms of operation, Nozh differs from contact. Instead of an explosive throw of metal, it uses shaped charge elements that destroy both shaped charge ammunition and subcaliber projectiles with counterjets. This was a significantly more advanced system. Reactive armor was installed not only on the turret, but also on the nose of the hull and on the sides. The fire control system received a new thermal imaging sight. The thermal imager allows for the detection of targets by thermal radiation, at night, in smoke, in fog, where a conventional night vision device is helpless. But all of this additional equipment had weight. The Bulat grew to 46 tons against 39 for the basic T-64B, and the old familiar problems with the running gear immediately returned. History came full circle. In parallel, the Kharkiv Design Bureau worked on another concept, the T-64E. Here they tried not just to hang new equipment on an old platform, but to rethink the role of the tank itself. The Nozh reactive armor complex was integrated into the design from the very beginning. This allowed for a more even distribution of weight and did not overload the running gear. The fire control system was completely redesigned, a new ballistic computer, and independent thermal imaging sights for the commander and gunner. This made it possible for the commander to look for the next target while the gunner worked on the current one, the hunter-killer mode, which sharply increased the rate of target destruction. The main innovation was the possibility of installing multifunctional combat modules in the turret ports. This meant that the tank could change its role depending on the task. The standard version was a classic tank with a 125mm gun. With additional modules, it became an infantry support vehicle, capable of working against fortifications and targets on the upper floors of buildings. The 125mm Smoothbore D-81T gun, which debuted on the T-64A in 1968, became the standard of Soviet and Russian tank building. It is installed on the T-72 of all modifications, on the T-80, and on the T-90. Its further development is installed on the Russian T-14 Armata. The Carousel-type Autoloader, first used on the T-64, also became a standard. The three-man crew, first implemented on the T-64, became the norm. Composite armor, first used on the T-64 in mass production, is used everywhere today. The machine lost the production competition, but won the conceptual one. It is not produced today, but everything that is produced is built in its image and likeness. This is not a consolation prize. This is a real legacy. Stories about technology are rarely only about technology. Behind each machine are decisions made by real people in specific circumstances. Morozov created a machine that was ahead of not only the enemy, but also its own industry, its own army, and its own system of training personnel. The tank was ready for what the rest of the system was not yet ready for. New technology does not exist in a vacuum. It exists within a system: production, logistical, and personnel. If the system is not ready for the technology will not survive, no matter how brilliant it is on its own. The T-64 was created without compromise. The best engine possible, the best layout possible, the best armor possible. The designer did not agree to second best anywhere and got a machine that was magnificent in ideal conditions. The T-72 was created with another question in mind. What will work always, everywhere, with any crew, and in any climate? The Army chose practice. The Autoloader removed the loader. This gave a reduction in the turret, an increase in the rate of fire, and a reduction in mass. But at the same time, the load on the remaining 3 crew members increased. The tight layout gave small dimensions but surrounded the crew with ammunition. An honest engineering analysis always requires calculating the full price of a solution, including what this solution makes impossible or dangerous. The T-64 was the first in the world with composite armor, the first with a Carousel autoloader in mass production, and the first with a 125mm gun. But the first position was not consolidated. Production remained limited. There was no export. The machine did not participate in real clashes. Being first without consolidation is a claim, not a victory. The 5 TDF did not have an evolutionary base. It was created revolutionary right away and paid for this with years of unreliability. The T-72 took a proven engine and added revolutionary armament to it. This is a more stable combination. Revolution where it is needed, evolution where it works. Morozov did not accept this principle. He wanted revolution everywhere at once, and in this was his greatness and his tragedy. There are people whose scale is appreciated by history during their lifetime. There are others, those whose scale becomes visible only later, when what they did begins to work in other hands, under other names, without mentioning the source. Alexander Morozov is from the second group. Morozov was born in 1904 into the family of a railway foreman in the small town of Bezhitsa, now part of Bryansk. He joined the design bureau in the early 1930s as a young specialist, in the midst of Soviet industrialization. His first major project was participation in the creation of the T-34. The work was carried out under the leadership of Mikhail Koshkin, a man of rare talent and rare stubbornness. When Koshkin passed away from pneumonia in 1940, contracted during the winter run of the first T-34s from Kharkiv to Moscow, Morozov took over the bureau. He was 36 years old. When the situation changed sharply in 1941, the Kharkiv plant had to be evacuated. Equipment was loaded into trains and transported across the country to the Urals, to Nizhny Tagil. There, in unheated workshops, under the conditions of the Ural winter, production of the T-34 was resumed in the shortest possible time. This was one of the most impressive production operations in history, and Morozov was at its center. After the end of World War II, he returned to Kharkiv. The T-44, T-54, and T-55, all of this was his work. 100,000 tanks worldwide. Hero of socialist labor. 3 state prizes. He could have quietly continued to improve what already worked, but he did not want to. The struggle for the T-64, for its adoption, for its funding, for its refinement, went on for years. The military department pressed for a reduction in complexity. Manufacturers complained about the lack of manufacturability. Competitors from Nizhny Tagil offered simpler solutions. Morozov stood his ground, not out of stubbornness, out of conviction. He saw what this machine should be and was not ready to back down from this vision. This conviction gave him the T-64, but it also closed his eyes to some obvious things. Morozov did not want to hear that the 5 TDF engine was too complex for mass operation. His logic was understandable. Do not lower the requirements for technology, raise the requirements for people. This is the right logic for a laboratory specimen. For a mass army with an uneven level of training, no. In 1976, the very year the T-80 was adopted, Morozov left the post of chief designer. He was 72 years old. Morozov passed away in 1979. He did not live to see the official termination of T-64 production by 8 years. He did not live to see the moment when his machine received a second life. In Kharkiv, there is Morozov Street. In the museum of the Kharkiv Design Bureau, his personal belongings, manuscripts, and workbooks are kept. But the main monument remains another. Take any modern tank created in the Soviet or Russian tradition. Look at the layout. 3 crew members, a Carousel autoloader, a 125mm gun, composite armor, and a low silhouette. All of this came from the Kharkiv Design Bureau. All of this traces back to the decisions Morozov made in the late 1950s. He lost the production race of his time, but he set the standards by which this race went further, already without him. Conversations about which tank is better almost always end in an argument, because better is not an absolute category. Better for what? Under what conditions? With what crew? Nevertheless, comparing the T-64 with its Western contemporaries is a meaningful task. Not to declare a winner, but to understand how much the Soviet machine actually was ahead of its time. The American M60 tank was the most mass-produced Western tank of the era when the T-64 only appeared. Adopted into service in 1960, it remained the main tank of the United States Army until the appearance of the Abrams in the early 1980s. In terms of layout, the M60 was absolutely traditional. 4 crew members, a rifled 105mm gun, and monolithic steel armor. Without an autoloader, without composite armor. The combat mass of the M60A3, the most advanced version, was 52 tons, against 38 tons for the T-64A. The difference of 14 tons is fundamental. A heavier machine is worse at crossing water obstacles, puts more load on bridges, and accelerates slower. Rate of fire. The M60 with manual loading gave about 2 rounds per minute. The T-64A with an autoloader gave 10, a 5-fold difference. To sum up honestly, in a direct one-on-one clash, the T-64A would have had an overwhelming advantage over the M60 in almost all parameters. The Americans understood this perfectly well, which is why they were in such a hurry to develop the Abrams. The Chieftain, adopted into service in 1966, was created as a direct response to Soviet tanks, but to Soviet tanks of the previous generation, the T-54 and T-55. British designers did not know enough about the T-64 then. The Chieftain weighed 55 tons in the Mark V version. Maximum speed was about 48 kilometers per hour against 70 for the T-64A. 4 crew members, manual loading. In terms of firepower, the Chieftain was a serious opponent. Its 120mm rifled gun penetrated almost any armor of that time. But in terms of the combination, rate of fire, mobility, weight, compactness, the T-64A had obvious advantages over it. It was the realization of this gap that pushed British designers to develop Cha-Bum armor, a direct response to Soviet composite armor. The Leopard 1 had a fundamentally different philosophy. West German designers deliberately sacrificed armor protection in favor of mobility. The Leopard 1 weighed about 40 tons and developed speeds up to 65 kilometers per hour. The armor was quite modest by the standards of the era. In a direct clash with the T-64A, the Leopard 1 found itself in a difficult position. The T-64A, with its composite armor, was significantly less vulnerable to standard Western ammunition, while its 125mm gun penetrated the armor of the Leopard 1 with large margins. The West Germans understood this, which is why work on the Leopard 2 was carried out from the early 1970s. By the early 1980s, the West finally created machines capable of competing on equal terms with Soviet tanks of the new generation. In terms of firepower, there was parity or a slight advantage for the Soviet tank in rate of fire. 10 rounds per minute for the T-64B against 4 to 6 for Western machines with manual loading. In terms of protection, there was a comparable level. In terms of mobility, the Abrams, with its 1,500 horsepower, had the advantage. But the T-64B had what neither the Abrams nor the Leopard 2 had, the ability to launch guided missiles from the barrel bore with a range of up to 4 kilometers. An honest conclusion. The T-64B and its Western contemporaries of the early 1980s were in roughly the same weight category. Neither side had an overwhelming superiority, which in itself says how serious the Soviet tank was. The figures and the technical characteristics are not just lines in a table. Behind each of them is a specific engineering solution, a specific compromise, and a specific story. Combat mass is 36 tons. This is 16 tons less than the British Chieftain and 5 tons less than the American M60A1. At the same time, the armament of the Soviet machine was more powerful. Crew, 3 people. All Western tanks of that time carried 4. Main armament, a 115mm Smoothbore D68 gun with a Carousel-type autoloader. Rate of fire, up to 8 rounds per minute. Engine, 5 TDF with a capacity of 700 horsepower. For a machine weighing 36 tons, this gave a power-to-weight ratio of about 19.4 horsepower per ton, an excellent indicator for its time. Maximum speed, 70 kilometers per hour on the highway. Range on the highway, 600 kilometers with additional external tanks. These figures do not mean that the T-64A was invincible. They mean that in each of the key parameters it was ahead of or on par with the best Western machines of its time. We have analyzed this machine by its parts: the engine, the armor, the gun, the running gear, the biography of its creator, the reasons for its failure, and the scale of its influence. Now, the conclusion. The T-64 was the first main battle tank in the full sense of this definition. Not a heavy tank with a big gun, not a medium tank with good mobility, it was the main tank, a machine that combined firepower, protection, and mobility at the same time without sacrificing one for the other. Before it, no one could do this. Morozov showed that choosing between protection, power, and mobility is not necessary. Due to composite armor, the autoloader, and the new engine, he created a machine that accommodated in 36 tons what had previously required 50. It was this that frightened the West. Not individual characteristics, the whole concept. Because the concept outstripped the capabilities of the system that had to support it. One factory, one engine that no one except this factory knew how to make, and demanding crews that had to be specially prepared. On the scale of a huge army, this turned out to be unsustainable. The T-72 did not win because it was technically better. It won because it was created for a real army, with a real level of training, real production capabilities, and real logistics. When you look at the modern Russian T-90 or its modifications, you see a machine that is technically a deep evolution of the T-72. But look closer at what it consists of. The 125mm gun is from the T-64A. The Carousel autoloader is from the T-64. The 3-man crew is from the T-64. Composite armor is a concept from the T-64. Guided missiles through the barrel were first used on the T-64B. The T-72 took the hull and engine. The T-64 gave everything else. This is not a metaphor. This is the literal history of how the tanks produced today are designed. Alexander Morozov did not wait for recognition in the form in which it usually comes to great designers, through the triumph of the machine they created. His triumph turned out to be different. Quiet, stretched over decades, poured into other designs and other factory numbers. Each time another tank of the Soviet or Russian school left the factory with a Carousel autoloader and a 125mm gun, it was, among other things, his result. The T-64 was too far ahead of its time, but precisely because it was ahead, the following machines were able to catch up. History does not always reward the first, but it remembers those who showed the way. Thanks for watching, friends. See you in the next video.